Hey, pre-calculus, how's everyone doing today? We're going to take a look at solving equations. We're going to start with this first one, and I just want to remind you the different ways we have of solving equations before we begin. Number one, our favorite way of solving equations is always to use inverses. Okay, if we can use the inverses, that is the best mathematical way to do it. Number two, our next way of solving equations is experience. If we have seen the equation before and we remember it, the answer hasn't changed. We can use experience to help us solve equations. Number three, an underrated technique that can still be used, usually as a last resort, but if you get to this point where you need to do it, it's perfectly valid. It's guess and check. And then number four, the last way we have of solving equations is through the use of technology. Okay, if you are stuck, these are the four methods we have of solving equations. Inverses is the tried and true. The only time inverses fails is if we are not experienced enough to know the inverse of a certain function. As long as we know the inverse, it's my favorite way of doing it. So let's take a look at our first equation here. 10 to the x plus 8 over 2 equals 54. How are we going to solve this? Well, the first thing we're going to do is we're going to use inverses. We want to get rid of this division by 2 right here. So to get rid of division by 2, we're going to multiply both sides by 2. And that's going to take us to 10 to the x plus 8 equals 108. Our next step is to make use of inverses again. We're going to subtract 8 from both sides, and we're going to get 10 to the x equals 100. Now, at this point in time, you probably are not familiar with the inverse you need. Okay, in step 1, you knew multiplication by 2 was the inverse of division by 2, so you were all set. Step 2, you knew subtraction by 8 was the inverse of addition by 8, so you knew what to do. But now in this one, how do you get rid of a base 10? That's probably not something you've learned, and that's where we're going to be headed as we do some of these lessons. So for now, your best bet is just to use experience. You think about it, you say, hey, 10 raised to what power equals 100? Either by experience or guess and check, you're going to figure out that this is x equals 2. So that is one way of solving this equation. I want to make it a little more formal, though. I want to take this 10 to the x equals 100. I want to look at it slightly differently. And I want to say there's something these two numbers have in common. So we're going to talk about common bases here, okay? Now remember, a base is anything that has an exponent. So the base on the left-hand side is 10. The base on the right-hand side right now, well, you could say it's 100 because it's 100 to the first. But what we want to do is we want to try to get something that we're going to call common bases. So is there a base that both 10 and 100 have in common? And that answer is, yeah, of course, it's 10. So if I say that my left-hand side is 10 to the x, and I change my right-hand side to 10 to the 2, what we can do now is we can make use of good mathematical properties that say, hey, we can do the same thing to both sides. So on this side, we've got a base 10. On this side, we've got a base 10. We know those two things are already equal. If the bases are equal, the exponents must be equal. And this is more of a formal way to figure out that x equals 2 in this problem that doesn't quite rely on guess and check. So again, what we're talking about is something called the method of common bases. I want to go through 2 or 3 more examples with you guys and then give you a homework assignment after that. So if you'll follow along, the next one we're going to look at is 8 raised to the x equals 32. The key here is figuring out what is the number base that both these sides have in common. So 8 and 32. Well, it's not going to be either of these two numbers, so we're going to have to think about other numbers that we can use that will work with 8 and 32. And hopefully, you're going to come up with the fact that both of them can be written as base 2 numbers. 8 is 2 to the third, and 32 is 2 to the fifth. So if I rewrite that over on this side, 8 is being raised to the x, which means I'm going to change that 8 to a 2 to the third being raised to the x. And on the other side, I'm going to use a 2 to the fifth. Now, laws of exponents, if you have a raised to the b, all of that raised to the c, that becomes a to the b times c. So I can keep my base of 2 and multiply my 3 by my x. And on the other side, I'm going to get 2 to the fifth. Now I've got common bases. If the two bases are equal, then the exponents must also be equal. So this is going to reduce down to 3x equals 5. And that tells me that x is equal to 5 thirds. So our final answer here is 5 thirds. Now, based on our last lesson, you should remember that we can use this x. We can always check our answer. We can go back and take this x and plug it into the original equation. That will give us 8 raised to the 5 thirds equals 32. Here's our rational exponent. We talked about that being power over root. So now if I use that idea of power over root to check our answer, this is really 8. And again, I prefer a lot of times to do the root first. The power here is the 5th power, but I'm going to do the cube root because it's the 1/3 to start with. So from here, I know the cube root of 8 is 2. That gives me 2 to the 5th. And 2 to the 5th is indeed 32. So this checks out. Okay, so having an answer of x to the 5/3 is perfectly okay. Next example I want to do is 9 raised to the x equals 1 over 27. Again, we're looking for a common base between 9 and 1/27. Hopefully you're going to get that is 3, because 3 raised to the 2nd is 9. 1 over 27 is really 3 to the 3rd on the denominator, which means to bring it to the numerator, I'm going to have to use a negative exponent. So that's going to be 3 to the negative 3. Going back to the original equation, 9 raised to the x is really 3 squared raised to the x, and 1 over 27 is 3 to the negative 3. That's going to give me 3 to the 2x equals 3 to the negative 3. At this point in time, I have got common bases. So if the bases are equal, the exponents must be equal. So 2x equals negative 3, which tells me that x equals negative 3/2. Again, just to check this answer, if I substitute that back in, I'm saying 9 raised to the negative 3/2 is equal to 1 over 27. We'll write question mark because we're going to check to see if that's true. First thing I'm going to do is use my negative exponent to make this 1 over 9 to the 3/2. Then I'm going to make it 1 over, the root is the square root, and the power is the 3rd power, power over root. So that's going to give me 1 over 3 to the 3rd, and that will give me 1 over 27. So again, it's all about a method of common bases. Make both sides share the same base. If we look at this next one, what we've got is 4 raised to the 3x plus 5 equals 1029. This one, the first step is inverses all the way. We know the inverse of addition by 5, so we're going to do subtraction by 5 on both sides. That's going to get me 4 to the 3x equals 1024. And now you've got to think about a common base between 4 and 1024. 4 is 2 squared, and for those of you who are familiar with powers of 2, you'll recognize 1024 is 2 to the 10th. If you're not familiar, that's okay. A little bit of guess and check will get you there. You'll have to use all 10 of your fingers to count up your powers of 2, but you'll get to 1024. So in this one, we know something raised to the 3x, and that something is 4. So I'm going 2 squared is equal to 2 to the 10th. Multiplying these exponents gets me 2 to the 6x equals 2 to the 10th. Like bases on both sides, so if the bases are equal, the exponents must be equal. So I get 6x equals 10. And from here, what I can do is I can say that x equals 10 over 6, and that will simplify to 5/3. So in this case, x is equal to 5/3. If I go back and substitute that in, I will get 4 to the 3 times 5/3. And now I'm saying this should equal 1024. Well, those 3's will cancel, and I'll be left with 4 to the 5th. That's equal to 1024. We're trying to prove this. And 4 to the 5th, if you do it out, you'll see that's 1024. If you take it all the way down to base 2, you'll get this as 2 squared all to the 5th. And that will get you 2 to the 10th, which is indeed 1024. So, method of common bases. One last thing to share with you guys. Don't underestimate the power of using inverses correctly. We're going to do a lot more detailed look at that in one of the upcoming lessons. Experience, guess and check, technology. What we're doing now is the method of common bases. That is really just another way of using our experience in a little bit more formal sense. So I hope all that makes sense to you guys. I'm gonna leave a little assignment for you guys to try. If you have any questions, feel free to email me. I hope you're all doing great, and we'll meet up sometime very soon. Take care, everybody.